Okay, so the motor has been running more or less continuously for about 40 hours at this point, and we've used 41 amp hours out of the battery pack, or 7,985 watt hours. So now this is interesting. You see how the motor RPM is still hovering at that 900 to 1,000 range, and we're pulling 48 amps at about 4 to 8 volts. Now this is weird because, as you can see, the motor RPM is actually dropping. And also, what I noticed when I came in this morning was that the motor was actually spinning quite a bit slower, and it was hovering at about 300 RPM. So for some reason, it's entered into this state where it's reducing its RPM down to a very low value, and then it hunts and comes back up. But this whole process takes several minutes. It's not consistent at all. So I'm not really sure what's going on with it. My guess would be that perhaps the Soliton is freaking out after being powered on for a long time. I did have an issue last night at about 1 in the morning. I came out and checked on it and noticed that the motor had stopped spinning entirely. This is the file that's about 111 megs worth of Soliton data captured by my program. But you'll notice that right at this point, it had gone in and everything was happily going along relatively fine. But you see, this is the RPM column, and it had been dropping down to 100 RPMs at this point, and then it just shut it off. So I think that's probably the limit on the Soliton, where like the idle function. If the motor gets below 100 RPMs, the idle function actually kicks out automatically. Because everywhere up in here it was above 100, but not by a lot. But then once it hit actually 100, it just shut off and powered down the motor. Now, I don't know why that happened. As you can see, I'm just kind of going up here a little bit. This is just, these are in milliseconds, and I can't remember exactly. Yes, I think these are actually straight up milliseconds. So, 200, 300, 400. So these are like 100 millisecond intervals for each line here. So everything was good. We were in the 800s for RPM, and then just a couple seconds later, it decided, nope, we're at 100, and it just shut off. Also, I noticed that right here, we're at 0 volts and 50 amps right before it shut off. Although up in here, we've got some 50s and a bunch of 48s. So I'm not really sure what happened, honestly. It could have just been that the Soliton freaked out after being running for 30 some odd hours straight and shut it down, or it could be that the motor, for whatever reason, decreased to 100 RPMs and it shut off. But anyway, not a big deal. It just kind of stopped my test in the middle here and stopped discharging at that point. So I'm not really sure. I have to figure out the math on how many milliseconds this was into the 30-hour thing. So we were at, what's that? 103,694,600 milliseconds. So whatever that math works out to for the number of hours before that kicked in, before that happened. Now in the background, we can hear that the motor has actually decreased in RPM quite a bit. So we're down to the 600s at this point, and falling. Not really sure why. Nothing's changed. The throttle is still at 0. And it's doing its idle function, But you know, we're 9 hours and 10 minutes after the reboot. So what I had done is, when the motor had stopped and I came out to get things going again, I closed the logger, mainly just to keep the log files somewhat under control. 111 megs worth of text file tends to blow up Excel, and I've got to pull it up into Word. That's why I was viewing it in Word. But anyway, so yeah, so now you can see we're at 270 RPMs, 50 amps at between 0 and I think I saw 8 volts on the motor. So something's going on. Not really sure what. I thought maybe the Soliton might have hit like a thermal limit, because there is no airflow on it, but it's at 102 degrees Fahrenheit, which is not really all that hot, and it's not even hot enough for the internal Soliton fans to kick on at this point. So it's like, okay, it's really not that hot. But anyway, so that's what's going on. See, we're at almost about 300 RPM now, and if I just sit here and let this do its thing, it will actually come back up to the 900s on its own after a bit when it feels like it. So I'm not really sure what's going on with the idle function. It's probably not designed to run for 40 hours continuously or 30 whatever, and so it probably just needs to be power cycled again. So I think that's what I'm going to do. I'm going to go ahead and we're going to stop logging. And actually, no, wait, I'm going to shut it off first, then we'll stop logging. One moment. Reach in here. I'm going to do this without hitting it. Okay, so I just shut the controller off, turned it back on again, and now we're going to stop logging. And then start again. Okay, so a curious thing happened when I reset the controller. Obviously everything went back to zeros here as far as the controller runtime and so forth. But okay, so the motor is not running. I'm going to actuate the throttle and we'll see what happens there. Bring her back up to speed. As you can see, the throttle the idle rather, is holding 950 to 1,000, somewhere in that range. Again, it kind of fluctuates, but so the motor amperage is fairly low, 33 to 48. I'm kind of seeing fluctuate, and the motor voltage is 6 or 7 volts. So we're going to go ahead and let this run for a little bit, and just to see what happens. So one of the things that I've been noticing is that the motor RPM will just drop, and it's interesting because it's still idling the motor, but it'll start going slower and slower and slower, down to about 275, give or take, RPM. And I'm not really sure why that's happening. I mean, nothing's changed with the setup. Everything's hooked up exactly the same way as it was. All the settings are the same. And yet, for reasons unknown, we're getting just the motor going down. So the last time I did this test, it took about 3 minutes, 3.5 or so, before the motor just started to slow down. I'm not really sure why, but we'll see if it happens again while I'm filming. course, as is the nature with such things, a watch pot never boils. So I'm going to go ahead and pause the recording. No, wait a minute. Wait, I see it. It's starting to drop. Okay, so we're down to 900, and there it goes. Dropped under 900. I can hear the motor spinning down to a slower rate. There it goes. Alright, so it took about 4 minutes this time before it randomly decided to drop down on speed. So you'll notice that the motor amperage is staying consistent, about 48 to 50. So it's just, still putting the same amount of current at the motor, but the voltage is dropping. And now we're down to 200 RPMs, 250 RPMs, and continuing to fall slightly. So I'm not sure why that's happening. It's not a motor over temp issue because there's no facility within the Soliton to check the temperature. That's kind of an artificial thing that I'm getting based on that input 1 voltage and calculating. Also, the Soliton temperature itself, 101 degrees, it's slightly above body temperature, which is definitely not like an overheat incident on that. The Soliton fans aren't even coming on, so it's not that hot. As you can see, the motor is now going back up again. So 500 and 600 and rising. So I don't know why it's fluctuating like this. It's kind of strange. But what I found, just doing some experimentation here, was that if I go into the settings, the Soliton settings, and I adjust the idle motor max current, we're going to go ahead and set that to 100. And again, just before I hit the button, let's go ahead and check. Again, it's dropping down 250, 230. And so I think this is what happened last night, is that it had gotten down to 100 RPMs, at which point it just shut off. And so not really sure why that's happening, but anyway, so we're going to go ahead and set this to 100. And immediately we can hear the motor spinning up in the background. We'll finish the refresh here. Okay, go back. So it's still limited to 50 amps for the maximum motor current, but now we've set the idle current to 100, which is kind of weird because it can't get there. But that seems to allow the motor voltage to raise up to the point where it can hold that RPM properly. I'm not really sure why. I'm not sure what the difference is. It might be because as the brushes seat, their characteristics of how they're transmitting the power to the motor, is, I'm assuming, more efficient as they're seated better, and maybe that somehow has a impact on the amount of voltage that can be passed through or something. I honestly, I don't know what the magic math is. That's why this is happening. But this is what I'm observing, and so thus I'm reporting on it. So basically at this point I've got it set to 100 amps for the idle current, and the maximum motor current is still set to 50, maximum battery current is set to 50, whereas the voltage can go all the way up to 170 if it needs to. But again, limiting it to that 50 amps. So because the amps roughly equals heat, I think that it's probably a good idea to keep that amperage limited during the brush seating process, and let the voltage go up to the NetGain spec if we need to, in order to hold that RPMs. But anyway, just kind of an interesting thing. Not really sure if it means anything at all, but at this point we're back up and running, and the motor is happily spinning away. And I guess we'll come back and check on this after another 30 or 40 hours and see where we're at. The pack amp hours, I'm not sure how accurate this measurement is. This is coming directly from the Soliton data, and so it's calculated based on the information that the Soliton provides as far as this is how much power I sent to the motor. We're down to 193 pack voltage under load, and I'm showing 192.5 on the JLD 404. So it has been consuming power, but sipping it, as it were. And so if this is any indication, my 36,000 watt hour battery pack that was more or less fully charged, we should have plenty of time to keep running this test before we run out of power. Anyway, I'll let y'all know what happens, give you an update after some more exciting things occur. Okay, so here's a close-up of the commutator, and this is after running the motor for roughly 40 hours. And I had set the Soliton for 1,000 RPMs. It ran at more like 950 is kind of where it settled out, and it did drop down a couple times to 200 RPMs, and it was kind of jumping around in there a bit. So can't say for sure exactly how fast it had been running, but definitely not much higher than 1,000 RPM, and usually in the 900 range. Anyway, so I'd gotten an email this morning from George Hiller, one of my subscribers, and he mentioned that Hellwig has a spec somewhere that their brushes need to be seated at 2,500 RPM, and that anything less than that, like anything as slow as what I've been running, would score the commutator. Now, I'm not sure if that's applicable to the National brushes that I'm using here, or if it's specific to a certain hardness of the Hellwig brushes, because they do sell them in various different hardnesses for different applications. And I can see that the harder brushes that are designed to I guess last longer would potentially have just because the material is harder, that it could maybe score the copper of the commutator. So my commutator looks okay to me. I mean, there are striations here that you can tell that there's like wear marks of where the patina is starting to be deposited on the commutator. It's not very dark yet, but I can see like a line in the middle where it basically hadn't been rubbing on the brushes. So stuff is happening. it is certainly wearing the brushes a little bit and leaving a trail on the commutator. I'm not sure if I'm on board with the whole scoring deal. It's possible that we're damaging the commutator here, but I don't think that's as much of a concern with these particular brushes, but maybe, who knows. But anyway, so he did bring up an interesting point though about the RPMs, and not so much for the scoring that I'm worried about, but the heat dissipation from the internal fan is based on how fast it's spinning. So I think that at 1,000 RPMs over a long period of time probably isn't gonna move that air as well, and so the temperature of the case is warm to the touch. I mean, it's not like scalding or anything, but I would say definitely warmer than body temperature at this point. So, which brings up another point. Another subscriber, Jarko, so we can pronounce his name right, Jarko Santala, had commented that Jack likes to remove the fans from these motors, and I think that generally that happens when he's trying to mount two motors together. So, for example, the two WarP 11s that are running in his Escalade,
and so in order to make room, they removed the fan blades from those. I don't think he's ever removed them from a standalone motor, even with the forced air cooling. So anyway, this definitely does have the fan blades in here, and you can see them spinning, and it does move quite a bit of air out of there. Also note that I did take off the cover band on this side because I wanted to have maximum airflow while the motor was doing this whole seating process and running for 40 hours straight. So I did do that, and I may rig up something for the forced air cooling later, but for right now, I think this will work just for sitting here doing the brush seating, and we'll come up with a plan after that. But anyway, so what I'm going to do is reprogram the Soliton to crank it up to 2,500 RPMs, which is the recommended value that George Hiller had said, and give that a shot. I don't see it doing any damage because it'll move more air, and that's always a good thing, as well as we've got a limitation of 50 amps on the motor, so we're really not going to be putting any more energy into the motor, but spinning it faster, or sorry, any more amps into the motor, but the voltage will be higher, and so it's going to spin the rotor faster and get that air moving. So anyway, I'm going to go ahead and make that change, and we'll see how that works.
Alrighty then. So based on user feedback from my viewers on YouTube, I'm going to make some changes to this brush seating configuration in order to ensure that the motor is properly cooled, and who knows, maybe there's something to be said for this whole scoring on the commutator by the brushes. Could happen. I don't proclaim to be an expert on such matters, so I'm more than willing to give it a shot. So anyway, so what we've got is the motor idling right now. It's at the 970 to 980 range, kind of fluctuating there. So we're going to go into the Soliton configuration again, and while it's running, we're going to go ahead and make this change from the idle motor speed from 1,000 up to 2,500. Now 2,500 is the maximum that you can set this at anyway. So if this doesn't work, we're kind of at our limit. But and we're going to leave the idle motor max current at 100, and let's do it. So it spiked up to about 2,700 RPM, and now it's kind of settled out at, 2,450, 430, somewhere in there. And again, it's still hunting a bit based on those values, but it's certainly spinning a lot quicker now than it was before. So we're pulling a lot higher voltage. And interestingly, and I guess not so surprisingly, we're pulling less amperage. So it's hovering between 18 and 40 amps and kind of jumping around in there, whereas the motor voltage is pushing up from 6 to 20, whereas before it was capping out well under 10. So I've heard it stated that voltage equals RPMs and amperage is torque. So I guess that kind of makes sense that if we raise the RPMs, it's going to require more voltage to get the job done. But I do kind of find it interesting that it's using less amps but more volts. Yeah, so anyway, so the motor is still limited in the settings to 50 amps for its maximum motor current, but the idle function is set to 100. Not really sure about that, why there's a discrepancy there, but that's how it works, or appears to work anyway. So we're going to let it chug and whir and sputter here, now at the 2,500 RPM range, the fastest that we can idle the motor at with the Soliton. And yeah, we'll let it go, and I'm going to go to work, and when I come back I'll find out how it turned out, or if my car is a smoldering pile of ruin on the floor. Also, I do notice that with the increased amp draw, We're now pulling 2 to 6 amps out of the pack, and the pack voltage is sagging a little bit more. Note also that the watt hours and the amp hours have been reset. That was due to a incident involving Microsoft Word, where I opened up a very large document to take a look at what was going on, and when I closed Word, it caused my Soliton program to crash. So, you know, software, gotta love it. So, anyway, I'm gonna let this chug and whir, and I'll get back to you later. Take care.